So here there is another theory part here, that is solution of homogeneous linear equation with constant coefficient. So already you know that linear equation with constant coefficient and linear equation with variable coefficient in unit 2 itself. Here they are defining linear system. So you can taking the system of equation. So you can taking two equations simultaneously at the time, and you can calculate the equation, linear system of equation with constant coefficient and linear system of equation with variable coefficient. Likewise, you have to calculate in this unit. For that, you have to use using that Wronski and W of t not equal to 0 term. That is the main thing here. So consider here solution of homogeneous linear system with a constant coefficient means there is some step to follow up that problem. We will see the problem part in the next class, but I will class. They are given of two. One is in x in terms of t and y in terms of t. So dx by dt equal to a1 of x plus b1 of y, and dy by dt equal to a2 of x plus b2 of y. So keep it as equation number 1 here. So step 1 is what? First of all, you have to do in that problem. First of all, you have to assume that x equal to a into e to the power mt and y equal to b into e to the power mt here. So substituting this x and y value in the equation number 1, that is dx by dt. So you have to differentiate this x with respect to t means what? Then it becomes, so a is a constant here. E with respect e power mt with respect to t means e power mt into t's coefficient is what? M here. So normally e power 2t means you have to differentiate it e power 2t into 2. Likewise here e power mt into m. You have to differentiating the term dx by dt. Similarly, you have to differentiating the term y, that is dy by dt, which is equal to b is a constant here. Again, you have to differentiate the term e power mt. So e power mt into m. That is the thing. First, you have to differentiate it. First of all, you have to identify the x, y term, and then you have to differentiate it, and then you have to substitute in that equation. You have to substitute the dx instead of dx by dt, dy by dt. You have to eliminate that. You had converted to into in a power a into e power mt form. So for that only you have to differentiating and substituting in the above equation. So the above equation changes into that is dx by dt value is a into e to the power mt into m, which is equal to a1 into x value is what? A into e to the power mt. Similarly, plus b1 into, in first equation, you have to substitute the y value here. Y value is what? B into e to the power mt here. So you have to substitute that thing also. And you have to, similarly, you have to substitute dy by dt equal to b into m into e to the power mt, which is equal to a2 into x value is a into e to the power mt plus b2 into, again you have to substitute the y value here, that is b into e to the power mt here. So you can take it as equation number 2 here, and you go to the step 3, that is dividing that entire equation by e power mt. Because you have to reduce the equation. For that purpose, you have entirely divide the equation by e power mt is common. So taking e power mt is common and dividing entirely. So the equation converted into the form a m equal to a1a plus b1b. Similarly, the second term bm equal to a2a plus b2b here. So now you can reduce it to a linear algebraic form here. That is what you can taking the power a as common here. Capital A is common here. So for that, you have to taking that capital AM to the right hand side. That is A into small a1 minus AM plus B1B here. So you can taking out the capital A common here. So the remaining term is A1 minus M is in within bracket term plus B1B equal to 0. Similarly, you can taking the term BM to the right hand side. So for that A to A plus, you can taking the term B common out here. So B2 minus M, that is the term which is equal to 0. Now you have to reduce this to a matrix form. For that, you have to equating that coefficient term. In the first column, you have to substitute the coefficient of A, that is A1 minus M, and A2 in the first column, that is step 4. And similarly, B1, coefficient of B is what? B1 and B2 minus M. That is substituted in the second column. Now you can taking the determinant for that value equal to 0 and equating to 0. You have to cross multiply that. That is A1 minus M into B2 minus M minus A2 into B1, which is equal to 0. Now you have to multiply it individually. That is A1 into B2 minus A1 into M. Similarly, minus M into B2 minus into minus plus M square here. And then you have to write it in a quadratic equation form. That is M square is the first term. And you have taking the M term common out. That is minus M into A1 plus B2 here. And then plus remaining the constant term, that is A1 B2 minus A2 B1 is the constant term here, which is equal to 0. So normally you have converting it into the quadratic equation means it is easily to identify the roots for the given problem. So you know already, if it is a real type root means you can write it as A into e to the power m1x plus B into e to the power m2x. And complex type means you can write it in the form e power alpha x a cos beta x plus b sin beta x. And similarly, the roots are equal means a plus bx into e to the power mx. Likewise, you have to derive the solution according to which type of root is occurred. So there are 3 types of solution here also. Types of solution here. That is a distinct real root. That is first type is distinct real root. For that you have to write the complementary function as x equal to c1 into a1 into e power m1t plus c2 into a2 into e to the power m2t. Here already in that unit 2 you have only enough to add only one constant there, that is a into e to the power m1x. Likewise, you have to derive, but here you have to differentiate with respect to t. So another constant term already is added in that first term itself, that is a into e to the power mt. Likewise, so here you have to adding the constant term, that is c1 and c2 here. So the general solution is of the form c1 into that a1 into e to the power m1t plus c2 into that a2 into e to the power m2t. If it is real and distinct means. Similarly, y can be written in the form c1 into b1 into e to the power m1t and c2 into b2 into e to the power is of real type means. If it is of complex type means the general solution. So e to the power alpha x into a cos bx plus b sin bx is the general format. Similarly, here you can differentiate with respect to t here. So you can write it as e power at and y equal to e power at into some term. So that term is c1 into a cos beta x means a1 cos bt minus a2 sin bt here plus again c2 into a1 sin bt minus a2 cos bt here. So a cos beta plus b sin beta is the function means you can write it as A1 is the positive term and A2 is the negative term. Likewise, you can take it. Here, beta t minus A2 cos beta t. So the reverse process is here. That is A cos beta minus A2 sin beta. That's reverse process is A1 sin bt minus A2 cos bt. So sin and cos are interchanging here. That is the and the second term is also added here. In that unit, you have to write only one term, but here you have to write it for the both the C1 term and C2 term. So if it is of distinct and complex means, similarly y equal to AT into C1 B1 cos BT minus B2 sin BT plus C2 into B1 sin BT plus B2 cos BT. Likewise, you have to memorize this formulas, and you can, using this formula, you can calculate the problem. And then if the roots are real and equal means the general solution is of the form x equal to C1 into A into e power mt plus C2 into A1 plus A2 into t plus e power mt. So in that second unit, you have to write ax plus b into e to the power mx. But in this unit, you have to first of all write it for C1 into A into e power mt. For the C2 term only, you have to write ax plus b format. That is a plus bx format means here the with respect to t. So a1 plus a2t into e to the power mt for the second constant term. Similarly, y equal to c1 into b e power m b1 plus b2 into t into e power mt. That